There's obviously a lot of excitement right now in the industry and in society in general about photovoltaics. Good, clean source of energy. Costs are starting to come down somewhat, which has always been a little bit of a limitation for PV. A lot of excitement about that. One of the concerns is that you can get significant variability, high ramp rates up and down as clouds pass over those, interrupts the sun to the panels. So there's a lot of concern with distribution engineers as to what kind of impact solar PV and high levels might have on the system. But because there's a power electronics front end that actually interconnects the inverters that interconnect those PV panels to the system, there are things that you can do through the power electronics in the way that you control that to sort of minimize some of that behavior. In addition to minimizing some of the potential adverse effects, those inverters provide you with the opportunity to actually support the system in a way that would be very beneficial to the system. Reactive power is one of the real concerns that you have on the system. There has to be sufficient reactive power to supply the inductance that's throughout the system, and reactive power to a large degree determines where your voltage is. If you are drawing a lot of reactive power across the system, then voltage tends to drop. The inverters provide you the opportunity to control those guys in a way to supply reactive power to the system to help maintain reliability and reactive power. And it's a potential significant resource to distribution system operators and even possibly to the bulk system to be able to control those PV inverters in a way to support the system. We actually have a couple of different projects where we have brought in inverters from all of the major inverter manufacturers, and we're actually putting those inverters through tests in the lab to understand how they will actually react to different things that occur on the system so that we can understand that interaction with the distribution feeder. But we also are testing them to see how they might be controlled in order to provide that resource. So we have the manufacturer provided inverters for most of the manufacturers that are supplying the PV manufacturers so that we can understand exactly how they behave so that we can model them well as we're doing this analysis of how they might be utilized in the system. This past week in Denver, there was a large solar PV meeting the entire week, and we presented the first work that's been done on how high penetrations of PV with these different control algorithms to provide from the inverters reactive power back to the system, how that might benefit the system in some of these detailed feeder models that we have. We presented that work. It was very well received. We had a significant amount of interaction and questions about the work and a lot of calls since then. We feel really good about being on the leading edge there to be able to help distribution engineers to know what might be available to them in terms of this new resource.